So now we have something very, very special for you, and we're so excited about that. We want to celebrate with you about a personality among us that has helped a lot the technical ecosystem in Greece.
We have announced it. It's time. Now it's time for the Open Ecosystem Award. For the first time, for the first Open Conf, we will give the award for the open ecosystem to a personality who has helped us a lot, considering all the technical difficulties that we have during the organization of this conference.
It's celebration about helping, in general, the technological ecosystem, not just about the Open Conference. He's a strong advisor of Open Conference, at least, but we are very, very small in front of his achievements. So welcome to stage, Mr. Diomidis Spinellis. Thank you so much for being with us. Give me just a second to give you the award. Dimitri, you can start telling us a few things about
Yes,
Diomidis.
of course. I will be the narrator of the deeds of Mr. Spinelis. Now, right now, he holds a PhD in computer science and a master engineer degree in software engineering, first-class honors, actually, from Imperial College of London. His research expertise, of course, speaks for itself, having big data applications, cloud systems engineering, and IT security. He has expanded, in general, the knowledge of computer science and technology. Professional-wise, we can say that he's a speaker and senior member of ACM, Association of Computing Machinery, senior member of IEEE, and a member of the Computer Society and the Eugenics Association.
He serves also as the president of the Open Technologies Alliance, GFOS. Professor Spinellis has actively promoted the use of open standards, free software, open content, open data, and open hardware in Greece, contributing to the growth of open technologies in the region. As one of the staunchest advocates of the open source software in Greece, Professor Spinellis has made significant contributions to the open source software ideology and has actively designed and developed open source software for over 3 decades.
And of course, we have award distinctions, software contributions. Throughout his academic career, he has received several honors. He has been designing and developing open source software since 1988. We have a great many list, Professor.
And a great many list of books for software development. We would like to give you the stage for 10 minutes to tell us a few things about yourself.
It's because we can keep going, and then we will not even scratch the surface.
Thank you.
Thank you very much, Professor.
Thank you all very much. My thanks go to the organizers. It's a great honor. And also to my mentors, my colleagues and co-workers, and my students. Some of them are here who have been with me throughout this journey. I was told that I could not use slides for this presentation. So allow me to give 10 lessons that I learned, and I think they apply for every one of us, through 10 objects I have had with me through this journey. My first computer, it had run at 256 kilohertz with 1.5 kilobytes of RAM. It came with a beautiful book that had in it programs that I could type in and use. And this taught me the advantage of reading code in order to learn how to program. And after losing a bet that I could write a small factorial program without an error, the importance of testing our code. Let's move on. I later graduated to larger systems, started using the IBM personal computer, which came with a reference manual, such as a technical reference manual that contained a complete BIOS disassembly, and I could also see how the processor worked. And through it, I found the importance of learning the whole stack from the bottom to the top, from processor instructions to the operating system, as a way to understand what the computer is doing. At the university, during a break, I was in a Saturday afternoon, I found in a dumpster a hard disk from a VAX computer. This should hold about 5 megabytes of data. Through this computer, I learned how to manage performance. It's very expensive to call the operating system to perform input-output. It was, and it still is, on our cloud servers. And also, through Unix that run on this VAX computer, I learned the power of the command line interface. I measured that I'm still running about 30,000 commands, commands. I'm issuing about 30,000 commands each year. And if you're interested in how to do it, I have an open, free course on edX on how to use Unix's extremely powerful command line interface. At the same time, I was programming in C, and when I was using pointers, I got various messages saying core dumped. This is an actual core memory based on magnetic cores. Through that, I learned the power of and the importance of debugging using techniques such as system call tracing, logging, and code and data breakpoints. By the way, if you don't know what data breakpoints are, learn them. They're extremely powerful debugging technique. I later put those down in the book, Effective Debugging. Working for a company that develops civil engineering software, they received a processor, a numerical coprocessor, about 1,000 euros in today's prices, that could speed up their finite element calculations 100 times. They asked me to insert it in the computer. I put it in. Magic smoke came out. I had inserted it in the wrong way. And this taught me a very important lesson. Be very careful when you do things that can break. It taught me they were quite relaxed about it, and they taught me the importance of trusting young people to do mistakes and learning from them. And also the importance of, as NASA says, fly what you test what you fly, and demonstrate margin. Later on, I had the privilege and joy to work with a one laptop per child computer, the one you see here. This made it possible and showed the world that we can create small, powerful computers that anyone can use. Today, millions of children use them in a very different form, such as smartphones and tablets, Raspberry Pis, and BBC Micro. On it, I built an emulator for the Antikythera mechanism, which taught me that the best way to learn how something works is to actually build it. At times, I was discussing with the engineer that built this mechanism more than 2,000 years ago, and also showed me the power of learning environments. I built it in Scratch. If you have children, introduce them to Scratch or to BBC Micro, which uses a similar block-like interface. This is a pad, a semi-used pad from the General Secretariat of Information Systems at the Ministry of Finance. I worked there at a time of crisis when salaries were being slashed, contracts were being terminated, and we were asked to do more and more things. There I learned, and this is applicable to all software development, that even in a time of crisis when you're in a death march, it pays to invest about half of your time in fighting fires, but another half on operational and process improvements. These pay immediately and, of course, in the longer term. Moving on, I worked as editor at the IEEE Software magazine. There I used an open procurement or an open hiring process to attract new people, and I saw them do marvelous things. Through that, I learned that open hiring processes, allowing anyone to apply and judging on their competence rather than who you know and what your network is, can pay dividends, as does getting great people and allowing them to work freely without interfering with their work. You've seen all this stuff. Let me share with you something else. As I told you, I was not allowed to do a presentation for technical reasons. So another lesson I have learned through these years is that no matter what technical or operational or red tape restrictions you have, you can always find a way to hack around it. Thank you. Finally, as last thing, during the pandemic, a system came out for contact tracing based on Bluetooth connections. We built, through the Open Technology Alliance, a device called Epidose that could work in this way and interoperate with phones from Google and Apple. It didn't take off in the end, and that taught me the most valuable lesson of all. The reason it didn't take off was not problems in technology, but things that had to do with people and organization. And through this, I learned that the most powerful thing is not technology, but people and organizations who work around it, such as this conference. Thank you very much.
You know what? You are the first person that came to our minds when we decided to do this thing with the award this year. And now that I'm thinking about it, I was the one that proposed that you should not have an official presentation, okay? And now I'm so happy I did that.
Thank you.
Thank you so much. Every time, you're excellent. Thank you so much.
Thank you.